The first law of thermodynamics states that the change in internal energy of a system, delta U, equals the net heat transfer into the system, Q, plus the net work done on the system, W. This means that you can only change internal energy by adding or gaining energy through work. It simply says that you can add to the internal energy by heating the system or doing work on the system. Delta U equals Q plus W. Flippin' physics! Today's topic is thermal processes. Anyone know the basics?
Oh. Isn't that the thing that holds coffee?
No, Tommaso. There are 4 different measurable processes in which either temperature, volume, heat, or pressure is kept constant.
Oh.
Correct, Sienna. Someone's done their studying. The 4 processes are isochoric, isothermal, isobaric, and adiabatic. Isochoric has a constant volume. Now this means that there is no work done. So W equals 0. In our formula, delta U equals Q plus W. Since W is equal to 0, U equals Q.
So if there's no work done in the isochoric process, then what does the graph look like?
Well, Tommaso, on a pressure versus volume graph, the area under the curve is equal to the work done. Therefore, the graph must be a straight line perpendicular to the x-axis during an isochoric process.
Good job, Sienna. Now on to isothermal. Isothermal has a constant temperature. Since the change in temperature is equal to 0, there is no change in internal energy during an isothermal process. This means that U is equal to 0. This means in our equation delta U equals Q plus W, Q is equal to negative W.
So what does an isothermal process look like on a graph?
On a graph, an isothermal process looks like this. Now this is called an isotherm.
Oh, I get it. So when you look at an isothermal graph, you can see the differences in the temperature by looking at the isotherms. Isn't an isotherm on a map connecting points that have the same temperature at any given time or average over a given period? And if you go down to the left, the temperature decreases, and if you go up to the right, the temperature increases?
That's absolutely correct, Tommaso. Now on to the third process. The third process is isobaric. In an isobaric process, the pressure is constant. The formula used for this process is W equals negative P V.
The graph should be easy for this one. Since the pressure is constant in an isobaric graph, the line will just be a straight parallel line to the x-axis.
The last process is adiabatic. In an adiabatic process, there's no heat flow and no heat taken or added. Now this means that Q is equal to 0. Now in our formula, delta U equals Q plus W, U is equal to W. Now, the adiabatic process on a graph and the isothermal process might look a little similar, but when you look closer, there's a difference on an adiabatic pressure versus volume graph. The slope increases at a greater rate than on an isothermal graph, so it looks like this.
Can you show me an example?
Picture this. You have a piston and a burner underneath it. There is also a mass on top. If you were to turn on the flame and leave it burning, and increase the mass on top of the piston, which thermal process would take place from A to B?
Isochoric. Since there is more mass added onto the top of the piston, it is harder for the gas to move it. This causes the volume to remain constant, even as pressure increases and temperature increases.
Spectacular answer. However, would any work be done in this process?
No, since the mass on top prevents the gas from pushing it up, nor would the gas compress further. Since the mass did not move any distance, no work was done.
Precisely, Tommaso. Just remember that the force from the pressure of the gas is exerted on all surfaces of the chamber. And if none of the surfaces are moved, then there can be no work done by the gas. Now, I want you to imagine the same piston with the same mass on top of it. If you were to administer even more heat by turning on the burner, what would happen to the pressure and what type of process would it be?
The pressure would remain the same since the mass exerts the same force of gravity on the same cross-sectional area of the piston. Since it's constant and the temperature is increasing, the volume must increase. Wow, this all connects back to the combined gas law we learned. PV over T equals PV over T. Physics. Radical, dude.
Wow, you're on fire with these answers right now. Get it? Fire, heat, physics.
What?
Okay, moving on. Now, with the same container, you remove the heat source and remove part of the mass. So from here to here. So there's only the original amount of the mass on top of the piston. Why would the volume stay the same? And what process is this?
The amount of force exerted on the piston will decrease because you are taking off mass. This causes the pressure to also decrease. By removing the heat source, the temperature of the piston will decrease. Thinking about the combined gas laws once again, PV over T equals PV over T. The pressure and temperature both decrease, and this causes the volume to remain the same. We know that when volume is the same, to think of the isochoric process.
Correct. Finally, we are going to keep the same amount of mass on top of the piston, but continue to decrease the temperature. So from here to here. What will happen?
Since the mass is the same, the force exerted on the piston will remain the same, causing the pressure to remain constant, even though the temperature is decreasing. Since the temperature is decreasing and pressure is constant, the volume will decrease. Won't this be an isobaric process?
That's right. Because the pressure is kept constant, you will have an isobaric process. You may not have noticed, but we just went through a full cycle. Our piston is now back to the original volume, pressure, and temperature. This means that this piston is equal to this one over here.
Wow, that's so cool.
Now translate the example we just went through on a graph and explain it.
Alright, since A to B is isochoric, that means the volume will stay the same, which means it'll be a straight line up. From B to C, it is isobaric, which means the pressure stays the same, which means it is a line parallel to the x-axis. From C to D, it is isochoric, which means it'll go straight back down because the volume remains the same. And from D to A, it is isobaric, so the pressure stays the same, and it will go back to where it started.
This is not an original Flipping Physics video. We do not take ownership over any of the ideas or formats of the original Flipping Physics creator. No animals or people were hurt in making this video except me, and a shout out to Wesley Whitehurst for his beautiful studio.